Welcome to the DIY Honda Garage channel. DTC P2401 refers to an issue with the evaporative emission (EVAP) leak check pump control circuit in Honda CR-V models from 2023 onward. This diagnostic trouble code, specifically indicating low voltage in the control circuit, suggests that there's a malfunction with the EVAP leak check module's vacuum pump when the powertrain control module (PCM) sends an off signal. The PCM acts as the central computer that monitors and controls various engine and transmission functions. When it detects abnormal readings, such as a low voltage output while the pump is supposed to be off, it triggers this DTC to alert the technician. Understanding the relationship between the EVAP system and the PCM is critical for accurate diagnosis. Any issues in this circuit can lead to increased emissions and may affect the overall efficiency of the vehicle. The troubleshooting process is necessary to pinpoint whether the fault lies within the circuit itself or within the PCM. DTC P2401 signifies that there's a detected low voltage condition from the EVAP leak check module's vacuum pump control circuit. The affected components in this scenario are primarily the EVAP leak check module and the powertrain control module, or PCM. The EVAP leak check module functions to ensure there are no leaks in the fuel vapor recovery system, which is crucial for minimizing harmful emissions. The vacuum pump, which is part of this module, generates a vacuum to check for leaks in the EVAP system. It's typically located near the fuel tank or in the engine bay, depending on the specific vehicle configuration. When the PCM sends an off signal to the pump, it expects no voltage drop. However, if low voltage is detected whereas it shouldn't be, the PCM will store this diagnostic trouble code as a fault indication. Understanding these components' roles is essential in diagnosing and repairing the system effectively. Several potential causes can lead to the activation of DTC P2401. Firstly, an internal failure within the powertrain control module (PCM) could lead to abnormal voltage readings and inadvertently store this DTC. Secondly, wiring issues, such as a short circuit, can compromise the integrity of the EVAP leak check module circuits, causing low voltage conditions. This could include worn-out insulation or improper connections, leading to undesired signals being sent or received by the PCM. An open circuit condition also poses a major risk of triggering this code. This occurs when there's a break in the continuity of the wiring harness. Finally, a faulty EVAP leak check module itself can cause this DTC to be triggered, especially if the module experiences an internal malfunction that affects its operational parameters. A comprehensive assessment of these components is crucial for effective troubleshooting. When DTC P2401 is triggered, several symptoms may manifest, indicating an underlying issue. The most apparent symptom is the illumination of the check engine light, CEL, on the dashboard, which alerts the driver to investigate potential problems. Increased emissions may also occur due to the improper functioning of the EVAP system, which is designed to recapture fuel vapors and prevent them from escaping into the atmosphere. This malfunction not only poses environmental concerns, but may also lead to the vehicle failing an emissions test. Drivers might also notice poorer fuel economy, as the combustion process may be inefficient if the EVAP system is not functioning correctly. Overall, the combination of these symptoms underscores the importance of timely diagnosis and repair to restore the vehicle's environmental compliance and operational efficiency. The first step in troubleshooting DTC P2401 involves turning the vehicle ignition to the on position without starting the engine. Once in on mode, you'll perform a diagnostic test using the Honda Diagnostic System, HDS. This system allows technicians to monitor various functions and tests related to the powertrain, including the EVAP leak check module. During this step, it's crucial to observe the results. If the HDS indicates that the leak check module test is not okay, this confirms that there is a malfunction in the system related to the low voltage problem. By confirming the issue at this stage, technicians can further narrow down whether the fault lies within the EVAP system circuitry or with the control exerted by the PCM, grounding the troubleshooting efforts in solid diagnostic data. In the second troubleshooting step for DTC P2401, it's crucial to focus on checking the external wiring circuit related to the EVAP leak check module, ELCMP. This involves a systematic visual and electrical inspection to identify any signs of wear, damage, or shorted wires. Technicians will look closely for any points of contact that might be shorting out against the vehicle chassis or other components, which could introduce unwanted low-voltage signals. Additionally, inspecting for open circuits is equally important, as a break in the circuit can prevent electrical signals from effectively reaching the EVAP leak check module. By isolating these issues, technicians can determine if the problem originates from the wiring itself or if it persists further along in the control system. Proper inspection techniques based on the established diagnostic protocols are vital in ensuring a thorough examination. The third step in the troubleshooting process requires disconnecting the EVAP leak check module connector, which consists of 8 pins, 8P. With this connector removed, technicians will perform continuity tests to ensure that each wire is still intact and functioning as expected. Special attention is given to check for any shorts where the wire may unintentionally connect with the ground, which can significantly affect voltage readings. This step involves using a multimeter to evaluate resistance levels. Typical readings should be greater than 1 mΩ when the circuit is functioning correctly. Any values below this threshold indicate a problem within the circuit itself, signaling either a short or a malfunctioning component in the control system. By following these outlined steps thoroughly, technicians can gather precise data to facilitate effective repair strategies. The final troubleshooting step focuses on assessing the powertrain control module, PCM, for any faults that may contribute to the activation of DTC P2401. Once the EVAP leak check module has been tested and isolated, the attention turns to ensuring the PCM is not at fault. This involves performing specific tests as outlined by the diagnostic protocol, which may include checking for proper signals to and from the PCM when the EVAP system is engaged. It's crucial to evaluate the test results closely to determine if the PCM is functioning as intended or if it's generating erroneous signals causing the low voltage condition. Depending on these findings, additional measures may be required, such as reprogramming the PCM or replacing the unit altogether. Keeping thorough records of all test results and observations is key to guiding the repair direction effectively. After conducting all necessary repairs related to DTC P2401, it is essential to perform final verification to ensure that the issues have been resolved. This involves confirming that the repairs made align with the original problems identified during the troubleshooting process. Once this is established, technicians should recheck the entire system functionality, particularly focusing on the EVAP leak check module circuit and the signals from the PCM. It's crucial to clear any diagnostic trouble codes, DTCs, stored in the PCM to reset the system, followed by a comprehensive test drive of the vehicle. During the drive, the technician should observe for any repeat activation of the check engine light and verify that all system parameters are within expected ranges. This final verification step serves as a crucial checkpoint to ensure that the repair work is effective and eliminates further issues from arising. Preventive maintenance is vital to ensure that issues related to DTC P2401 do not recur. Regular checks of the entire evaporative emission (EVAP) system are essential. This includes assessing lines and connections for any potential leaks or signs of wear that could lead to malfunctions. In addition, routine inspections of wiring, specifically that related to the EVAP leak check module, should be performed regularly to prevent shorts or breaks in the circuit. Technicians should also consider updating the PCM software periodically to ensure that any bugs or glitches are resolved and that the module operates optimally. By implementing these preventive measures, vehicle owners can maintain a healthy EVAP system and reduce the risk of low voltage issues being triggered again in the future. In conclusion, understanding the function of the evaporative emission EVAP system is crucial for effectively diagnosing and repairing issues indicated by DTC P2401. Following the troubleshooting steps methodically allows technicians to isolate the fault, be it in the wiring, the control module, or the vacuum pump, leading to precise repairs. Each step should be conducted thoroughly, ensuring accurate readings and outcomes. Furthermore, regular preventive maintenance practices play a significant role in sustaining the EVAP system's integrity, ultimately contributing to the vehicle's performance and environmental compliance standards. By adhering to these principles, technicians can not only resolve current diagnostic trouble codes, but also mitigate the risk of future issues effectively. Please like and subscribe to the channel. See you next time.